This video is about using the graph and division to find the factorization of polynomials and also to solve when we have polynomial equations. So let's start by illustrating using some examples. First of all, looking at the first graph we have, notice that it has the first side of the graph starts down and the second side goes up. This side over here, since it ends going up, is a positive leading coefficient. So we know that if we're doing a factorization, we don't have to put a negative in front of it. Now we look at the graph and see where the intercepts are, and notice that the first intercept is at -3, the second one's at -1, and then over here we have an intercept at 4. And so the factorizations, when it crosses it has an x-intercept of -3, our factor is x plus 3. When it crosses at -1, that's an x plus 1. And when it crosses at 4, it's an x minus 4. So our factorization, our polynomial for this will be x plus 3, x plus 1, and x minus 4 because of the x-intercepts. And again, because the leading coefficient is positive, we don't have to put a negative in front of it. Now this second example here, notice that the right side of it does go down, so that means the leading coefficient is going to be a negative. So immediately I'm going to put in my factorization a -1 at the very front because I know that it's going to have a negative to make it end down. It's also going to be even. Let's look at the intercepts. This first intercept is at 2, so it's going to be x plus 2, because it's at -2, you do the opposite. And since it bounces there, or it goes both directions the same direction, it's a multiplicity 2. The next one, it goes through 0 here. Now, when it goes through 0, that means that x is our factor. And because it kind of slopes in gradually and then slopes out, that's going to be an x cubed. Or it could be an x to the 5th, or it could be an x to the 7th. We're going to, for purposes of our work here, going to assume it's an x cubed. And then over to the right here, it goes through at x equals 3, and so that would be a factor of x minus 3. And notice it just goes straight through, and so since it goes straight through, it's just a single factor. So our factorization will be x plus 2 squared times x cubed times x minus 3. And notice that my exponents here on the variable quantities are a 2, a 3, and then the x minus 3 is a 1. If I add those to get the total degree, I get a 6, which means it's even. And notice that both of them go down, so it is going to be even. I'd like you to pause the video and try the next two. See if you can come up with what the factorization will be of the next two just by practicing what we just talked about. So pause the video, try the next two. Now that you've tried these, let's take a look at what we got for these. So the first one here, because it starts up and ends up, that's going to be even, and they're both up, we're going to have the right side tells us, since the right side is up, it's going to be positive leading coefficient. Now the first intercept is going to be -1, so I have x plus 1 for an intercept for my factor. And then on the right side here, it goes through at 2, so that's x minus 2. And they both go straight through, so we don't put like a 3 or a 5 or 7. It has to be odd. When it goes through, it doesn't bounce. So my factorization will just be x plus 1 times x minus 2. The next one, notice that it starts up and ends down. That's going to be an odd function. Since it ends down, that's going to be a negative leading coefficient. So I'll immediately write a -1 as part of my factorization to have it start with the negative. And then it starts here with at -2. And so that's going to be an x plus 2 and it's going to be squared because it bounces there. This next one, notice it bounces at x also, so that's going to be an x squared. It could be a fourth power, a sixth, another even power, but we're going to assume the least since we don't have more information. And then it goes straight through at 3, so that means it's going to have a factor here of x minus 3. So my factorization will be negative 1 times x plus 2, the quantity squared, times x squared, times x minus 3. Okay, so that's how it would look factored. Now, what we're going to do is we're going to look at how we can factor or solve using division as part of the process. So next, the steps we're going to use is, first of all, you're going to graph it. And from the graph, you're going to find a factor from where it crosses at a nice, neat number, an integer somewhere. Unless a factor is given, it might be that they'll start off by saying x plus 2 is a factor, and then we'll use that. But otherwise, we're going to look to the graph first, then use division to find the quotient, factor the quotient if possible, and then if solving, set the factors equal to 0 and solve. So next, let's look at the example x to the fourth minus 7x squared plus 12. We're going to look at the graph of it. And if you sketch this on your calculator, what it's going to show is that it comes down through negative 2, then it comes almost right back up between negative 1 and negative 2, and then it goes through between 1 and 2, and then comes straight through at 2. So it goes through at 2, at negative 2, but then there are these two answers that we're not sure about because they're going to be decimal answers. So how you start this one is you look to see, you capture one of the numbers. This is going to be a factor of x plus 2. This will be a factor of x minus 2. So we need to start with one of them. I'm going to start with the x plus 2, and I'm going to divide that in. So if I'm dividing x plus 2 in, I'm going to start with a negative 2. Remember, you do the opposite of it. I'm going to use synthetic division to do my division. Then I'm going to have a 1 for the coefficient in front of x to the fourth. Now there's no x to the third, so I've got to put a placeholder in, 0x to the third, minus 7x squared, 0x, I've got to put a placeholder in there, and then a 12. Leave a line, draw a line, bring the 1 all the way below the line there. Now I'm going to take negative 2 times 1, get negative 2, add straight down, you get negative 2. Negative 2 times negative 2 is a positive 4. Add straight down, you get a negative 3. Negative 3 times negative 2 is positive 6. Add straight down, you get a 6. Negative 2 times 6 is a negative 12. Add straight down, you get a 0. We should get a remainder of 0 because if we don't, then it shouldn't have gone through at negative 2. That means that it is a factor, and that means the remainder will be 0. So this quotient is going to be 1 degree less than the x to the fourth, so it'll be 1x to the third minus 2x squared minus 3x plus 6. Now I'm going to take that one and divide it by the other factor, the x minus 2. So I'm going to take and put in the box, I'll put positive 2, and then I'll take my coefficients of this new quotient, 1x cubed minus 2x squared minus 3x plus 6. I'm going to do division again. Leave a line, or skip a line, draw a line, bring the 1 down. 2 times 1 is 2. Add those together, you get 0. 2 times 0 is 0. Add that straight down, and you get a negative 3. 2 times negative 3 is equal to negative 6. Add those down, and you should get a remainder of 0. So start with 1 degree less than the x cubed, so it'll be 1x squared minus 3, and then with the remainder of 0. So that x squared minus 3 is not the difference of squares, so it can't be factored. So my factors from the graph are x plus 2 times x minus 2, which is part of the factorization of this one. So I don't use this factor, the x cubed minus 2x squared minus 3x plus 6, because I divided it once more by x minus 2, and then I ended up with x squared minus 3. So my final factorization of this, we get two of them from the graph, and then we divide twice to get the last factor of x squared minus 3 to factor it. Now let's do the last one here. We're going to do solving this equation. And solving this equation will be, what we're going to do is we're going to first of all factor it and then set all the factors equal to 0. So remember the one we just did, we just factored it, so we didn't set them equal to 0 because there was no equation to start with. This one has it equal to 0, so we're going to go ahead and solve it. So a quick sketch of this graph, it has that goes out here, goes through at, it looks like at -4, and then between, it goes through the axis between 0 and -1 and 0 and 1. So the graph comes up, goes through -4, goes through here, comes down, okay, and then keeps going, and it comes back up just before it gets to 1. And so what I'm interested in is this one right there. It goes right through at -4. So my factor is x plus 4. So I'm going to use that to start off my my factorization of this in order to solve it. So I'm going to take and I'm going to put, using synthetic division, I'm going to put -4 in the box. I'm going to put my coefficients 9, 36, -4, and -16. Leave a line, draw a line, bring the 9 all the way underneath. -4 times 9 is -36. Add those, I get 0. -4 times 0 is 0. Add straight down, you get -4. -4 times -4 is positive 16. Add and you get 0. Again, need that remainder of 0 in order for it to be a factor, like it went through the graph at -4. So now I'm going to have my factorization here be 1 degree less than the cube I had, the 9x cubed. This will be 9x to the second plus 0x minus 4. So there's one factor. My original factor I got from the graph was x plus 4. So my equation that I now have through the graph and division is having x plus 4, where I set that equal to 0. X plus 4 equals 0. Subtract 4, you get x equals -4. And 9x squared minus 4 equals 0. That's going to factor into 3x minus 2, 3x plus 2. Okay, I'm going to take them up here and go ahead and set them each equal to 0. 3x minus 2 equals 0. 3x equals 2. X equals 2/3, which matches the one that's between 0 and 1. And then 3x plus 2 equals 0. Follow the same steps. 3x equals -2. X equals -2/3. So my answers are -4, x equals 2/3, and x equals -2/3. So what we have here is a procedure to factor polynomials and use the graph to do it, and also division in order to get factorizations, and when necessary to also solve. So we can use our factors from the graph, from division, to factor polynomials and to solve polynomials.